Welcome to Lesson 10.7, Rotational Symmetry and Rotations. Today we're going to talk about how to identify rotational symmetry, how to find the angle of rotation, and how to rotate a figure about a point. First, we need to know what is a rotation. A rotation is a transformation that turns a figure about a fixed point. Right, so if I have, let's use a square, and then I can have a point. Rotation is when I take that square and I move it about that point, but I have to remember that it doesn't just go like this, it actually has to turn as it goes. So if it's here, it's going to tilt a little bit as it turns because this corner has to stay the same distance away from that center point the entire time. It's like there's a string that's attached from the point to the corner. Yep. Now, that point of rotation or the center of rotation can be anywhere. So it's not always going to be where the point is here and the shape is out here. It could be that the point is in the shape itself. Rotational symmetry is when a figure can be rotated around a central point 180 degrees or less and match the original figure. A central point is called our center of rotation, the point a figure is rotated around. Right, so in this case, when I rotate this figure like this is that center of rotation. Right, so example 1, if I take this shape and this center of rotation is right here, and I turn it, it does not match exactly with the shape in its original form, so right now it doesn't have rotational symmetry, but once I turn it half of a turn, within that 180 degrees, it does match. So because it does match up within 180 degrees, it does have rotational symmetry. All right, example number 2. If I take this shape, and this star is here just to help me remember where I started, and I turn it a quarter turn, or 90 degrees, it does not match up with the original. If I turn it 180 degrees, it still does not match up with the original. And even if I turn it 270 degrees, it doesn't match up with the original. It takes one full turn of 360 degrees to get it to match up with the original. Therefore, this shape does not have rotational symmetry. Okay, so let's try a couple of these. If I take this shape and I rotate it 90 degrees, okay, I'm actually going to copy and paste. That might help a little bit. Right, so if I take the original shape, now if I rotate this 90 degrees, does it match up with the original shape? Or match the original shape? Nope, so it does not have rotational symmetry yet. Okay, if I take it and try to rotate it again, it still does not match up with the original. Therefore, since in 180 degrees, since it did not meet up, this shape does not have rotational symmetry. Right, so we can try the triangle. If I take this triangle and I rotate it 90 degrees, it does not have rotational symmetry. And again, it doesn't meet up in the 180 degrees. So again, this shape does not have rotational symmetry. Okay, we can try this one. If I rotate it 90 degrees, it does not match up. But now if I rotate it 180 degrees, it did match up. So this shape does have rotational symmetry. And again, we can try with the octagon. Now if I turn this, I don't even have to turn it a quarter of a turn, and it already matches up with itself. So we know right off the bat that this does have rotational symmetry. In your notes, you have these two problems left. I want you to determine if you can rotate these and if the shape has rotational symmetry or not. What might help you is to get a piece of paper, trace the shape, and then cut it out and actually physically rotate it. And then on Edmodo, you can post number 1, and you can just post yes or no for whether or not it has rotational symmetry. Okay, but we're not done yet. We still have to talk about the angle of rotation. The angle of rotation is the number of degrees a figure rotates before it matches its original figure. Right, so in this case, we talked about how if we turn this one 90 degrees, it matches up to its original figure. So how do we figure out this angle of rotation? Okay, because it started from here and we rotated it this way. Well, we take how many sides or points this shape has. It has 360. And it has 1, 2, 3, 4 points. In this case, we're going to use points. And we divide it. And we know that 4 goes into 360 90 times. So this angle of rotation is 90 degrees. So because this does have rotational symmetry, we know that if we rotate it 90 degrees, that's the first time that it'll match up with its original form. In this case, we have a 1, 2, 3, 4, 5, 6-sided figure, which we call a hexagon. I know that if I take this figure and rotate it, it's already matched up with itself. Because this figure has 6 sides, I'm going to take those 360 degrees. It has 1, 2, 3, 4, 5, 6 points. 36, or 6 goes into 36 6 times. So 6 goes into 360 60 times. So this angle of rotation is 60 degrees. It only takes 60 degrees for this figure to match up with itself. Right, with this trapezoid, we know that it does not have rotational symmetry because it will not match up with its original figure. So the angle of rotation here would be none, not 0. If you put 0, that doesn't tell us anything. That doesn't tell us that there is no angle of rotation. You have to put none. Again, this arrow, if you rotate it, does not match up with its original form, okay, because it points the opposite direction. So once again, this shape will have no angle of rotation. Now this shape we automatically know does because it is a regular octagon and it matches up with itself here. So since it has the 8 points, we take the 360, divide by 8. 8 goes into 36 4 times, subtract 32. 8 goes into 40 5 times. So the angle of rotation for this shape is 45 degrees. Right, so what I want you to do in your notes, you have these two figures. This will be your number 3 and your number 4. I want you to figure out what the angle of rotation is that will transform this from the red turning to the yellow. The red turning to the yellow. So it does have rotational symmetry. You need to tell me how many degrees it would take to go from the red to the yellow. Each one of these, so this is 1, 2, 3, 4, 5, 6 points, and this is 1, 2, 3, 4, 5 points. Again, if you have any questions, make sure to post them on Edmodo or write them down so we can go over them in class.